That is getting close to that. Keep coming. There. Slow down a bit. You start holding those hands coming in. I can put in track. So the mount needs to stop here. Up. Good.
Oh, wait.
Alright, going. Full ridge. Okay. Rolling forward. Full ridge. Let's keep going up. Right side good. Up. Go. Moving forward. Going forward. Go. That's it. Left. Good. All right. You got a weight?
460.
Same on this side.
Oh, these guys are still.
My name is Paul Deese. I'm an aerospace engineer with NASA's Armstrong Flight Research Center. I work in propulsion integration and test for the X-59 aircraft. We just installed the engine into X-59. It's a General Electric GE 414-100 engine for the X-59 aircraft. So this engine is a GE F414-100 engine. It's an engine specifically designed for single-engine aircraft. The X-59 is a purpose-built aircraft to show that we can quiet the sonic boom. If people are familiar with sonic booms, they're very loud, can be very disruptive, but over the last 10, 15, 20 years, NASA has been working on technologies to quiet that sonic boom into a sonic thump. We've rolled all of those technologies into X-59 to prove that it is actually capable to create a quiet supersonic aircraft. So the engine is what powers everything. It's what gives the aircraft thrust, moves it through the air, and eventually is what gets it going to the supersonic speeds where we'll test the X-59's capability to create a quiet sonic thump. So we just installed the 414 engine into X-59 at Lockheed Martin Skunk Works in Palmdale. The three team members who were a part of this, or three organizations, was NASA, Lockheed Martin, and General Electric. Each portion of the group came together to help with the actual install. We had mechanics, technicians, engineers all down on the floor, getting the engine in there safely and making sure that it was installed properly. Because we're using a 414 engine, there's already ground support equipment to help lift the engine up into the aircraft. We used standard F-18 equipment to lift the engine into X-59, but the process for us is a little bit different. F-18s have rails and are a little bit easier to maintain and to do that lift, that install. But when you're doing something for the first time, and especially on a one-off aircraft, we had a lot of people around with eyes on in different places to make sure that the engine didn't come into the contact with the aircraft and vice versa, so that nothing was damaged and the engine was safe once it got up into the airplane. As far as our group is concerned, what comes next for the propulsion group is we're going to keep supporting the aircraft during its build cycle. So if you've seen a picture of the aircraft, there's with the engine hanging, there's still kind of a big gap underneath the airplane. So the lower empennage still needs to go up, and that's another huge milestone for the integration of the whole aircraft when it comes together. I'm very excited. My group and the people that I've been working with between Lockheed, NASA, and GE have been working on this for about 4 years now. To get to this one singular moment. And so to see that actually come to fruition is every engineer's dream.